So this is the 2016 Leaving Cert Ordinary Level, Paper 2, and we're looking at question number 7. The Atomium in Brussels is one of Belgium's most famous landmarks. It consists of 9 identical spheres joined by 2 types of cylindrical pipes. The atomium is modelled on an iron atom that has been magnified 165 billion times. Given that a billion is 1,000 million, write 165 billion in the form A multiplied by 10 to the power of n, where n is an element of the z set, which is the set of integers. You can find that in your tables book, the z set. And a is greater than or equal to 1 but less than 10, so a is between 1 and 10. Okay, so 165 billion. Well, 165 billion is 1,000 million, so let's do a million first. A million is 6 zeros. And if we have 1,000 of them, we're multiplying. 1,000 has 3 zeros, so that's another 3. So there we have 165 with 9 zeros after. That's 165 billion. Now we want to write it in standard form. So to write it in standard form, you're going to express this in this general shape here. Some number multiplied by 10 to the power of another number. And the first number a must be between 1 and 10. So if you move the decimal would be here. If you moved it back to this position here, you would move it from here, where the decimal actually is. You'd move once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, 11 times to get it back here. So it would be 1.65. So 1.65 multiplied by 10 to the power of 11 would be the same as this number, 165 billion. So if you had 1.65, you multiplied it by 10, 11 times, you'd move the decimal all the way back here. So that's the answer in standard form. And you can see that A is 1.65, which is between 1 and 10. And our n value is 11, which is an integer. You can also do this in your calculator. If you just type the 165 billion into your calculator and change the setting on your calculator to scientific notation, and it will do it for you when you press equals. Okay, part B says the diameter of each sphere in the atomium is 18 meters. Find the radius of each sphere. Okay, well the radius is the diameter divided by 2. So that's 18 divided by 2, which is 9 meters. So that's the radius. B part 2 says find the volume of each sphere, correct to 2 decimal places. Okay, well the volume, I've taken this part here from the tables book, these formulas for a sphere. So you can see the volume is 4/3 pi r cubed for a sphere. 4/3 pi or cubed. So we're going to 4/3 by pi, we're going to change the or to 9 cubed, and then on the calculator that will give us gives me 972 pi. Now they want it to correct to 2 decimal places, so when I get 972 pi, and I press the SD button, that will give me 3053.628, and on it goes. But to 2 decimal places, I'm going to look at the 3rd digit after the decimal and ask myself, does this affect the 2 in front? Yes it does, it will make it go up. So my final answer is 3053.63. And that's going to be volume, which is meters cubed. So that's my volume for one sphere. Okay, part C says find the combined surface area of all 9 spheres in the atomium, correct to the nearest meter squared. Okay, so surface area is given by this formula here, again in the tables book. surface area is 4 pi or squared. So that's going to be 4 pi by 9 squared. And that's giving me an answer of 2916 pi. Okay, so that's not giving me that answer. It's giving me an answer of 324 pi. Okay, and then that's just one sphere, the area of one sphere, but we know that it's 9 spheres, the combined surface area of 9 spheres. So I'm going to multiply that by 9. So 9 by 324 pi gives me 2916 pi. And that's equal to, when I press the SD button, 9160.88, and on it goes. But if it's to the nearest meter, I'm going to look at the first digit after the decimal. Does this affect the 0 in front? Does the 8 affect the 0? The answer is it does. So the answer is 9161, and it's meters squared because it's surface area. Okay, part D says each of the 8 cylindrical pipes extending from the center sphere has a radius of 1.65 meters and a length of 23 meters. Find the sum of the curved surface areas of all 8 pipes correct to the nearest meter squared. Okay, so again, I have taken these formulas here from the tables book for a cylinder. So we have the formula for the curved surface area here, which is 2 pi over h. So the area is 2 pi or h, where or is the radius and h is the height. So that's going to give me 2 pi, a radius of 1.65, which is in meters. So watch out for your units. And h is 23 meters. The length of the cylinder, or the height of the cylinder, is 23, again in meters. Okay, so when I put all of this into the calculator, I end up with 600, no, gives me right, that gives me 759 over 10 pi. So that's the area of the surface area of one of the cylinders. What we want to know for 8 pipes, so it's going to be 8 times this. 8 by 759 over 10 pi. That gives me 1907.575, and on it goes. When I press the SD button, it gives me this, but they want to know what is it to the nearest meter. So I look to the digit after the decimal. Does this 5 affect the 7 in front? Yes, it does. So my answer is 1908 or 1908, and this is meters squared. Okay, D part 2. The other 12 cylindrical pipes connect the outer spheres to each other. Each pipe has a radius of 1.45 meters. All 12 pipes are equal in length. The sum of the curved surface areas of the 12 pipes is 3,170 meters squared. Find the length of one pipe and give your answer correct to the nearest meter. Okay, so we're given the surface area of all 12 pipes. So the first thing would be to find out the surface area of one of these pipes. So 3170 divided by 12. That gives me 264.16 recurring. So that's the surface area of one of the pipes. Okay, so now I know that the formula for the surface area of a cylinder or a pipe is 2 pi over h. So I know that 2 pi over h will be equal to this 264.16 recurring. And I know that the radius is 1.45 and I'm looking for the height. So I could plug in the radius for 1.45, the radius. Plug this in there for the radius. So that gives me 2 pi 1.45 h, which is equal to 264.16 recurring. 16 recurring. Okay, and now I'm looking for h, the height, so I'm just going to divide both sides by everything other than h. So divide this by 2 pi times 1.45. And if I do that to the left, I must do it to the right. 2 pi by 1.45. So here the 2's cancel, the pi's cancel, and the 1.45's cancel. And I'm left with h is equal to all of this, which I put into my calculator. And that gives me 28.997. And on it goes. But I want my answer, the length of the pipe or the height of the pipe, to the nearest meter. So my answer then would be, if it's to the nearest meter, does this 9 affect the 8 in front? Yes, it does. So the height is 29. 29, that's 29, that's in meters. Okay, so the final part 3, D part 3. The curved surface areas of the 20 pipes and the 9 spheres are covered in stainless steel. Stainless steel costs €70 per square meter. Use the areas you have calculated or have been given above to find the approximate cost of the stainless steel required to resurface the atomium. Okay, so I need to go back and find all my surface areas. So I had 1908 was one of them. I had the 3170, which was given to me. And also I had the surface area of the spheres, the 9161. So they were all of my surface areas. So when I add them together, I get 14,239 on the calculator. So it's 14,239 meters squared. That's the total surface area. Total surface area. Okay, and if it's €70 per square meter, then it's 70 multiplied by this. So 14,239 multiplied by the 70. And again on the calculator then that gives me 996,730. And that's going to be in euro. So almost €1,000,000 to paint it. 996,730 euro. And that's the end of the question.